Target, okay, and then there's a jeans sale going on. But
God.
oh my God, there was just a mountain of jeans. Like people are putting the jeans back or looking for the sizes, and the associates were supposed, the clerks were supposed to fold, they hadn't. So I walk up to the front, okay, I'm a badass. I walk up to the front, can I talk to the manager here? And they're like, yeah, of course you can. Is anything wrong, sir? I said, call the manager. Like exactly because I'm role playing. I said, call the manager. And then the manager comes rushing, is everything okay? And I said, I was out shopping for a pair of jeans, and there's just a mountain of jeans, a horrid pile there. Okay? I'm sure you have someone you're paying to clean that up, but they're not doing their job. This is the language I use. They're not doing their job. You need to fix it. You need to take care of it. And I'm just telling you, because of that, you lost a customer. And I walk out. And they're like, I'm sorry, sir. Thank you for letting us know. I'm like, I'm out of here. Oh, but no, here's the actual funny thing. See, I wasn't out looking for a pair of jeans. I wasn't. But I scolded them like, oh my God, guys, I was watching out for you. If you were out at that Target looking for men's jeans, it was a mess. No, I just walked out. I wasn't looking for jeans. But I just wanted to scold them because it was terrible. It's just a mound of jeans. He's saying Yelp reviews. I go and put in a bad review for Target.
Yeah.
Okay, guys, copy down. It's a word problem. It's very easy though. Copy down that paragraph. I'm going to scroll down. Okay, copy down that problem. So when this dies, the screen is still on, right? Okay, as in the video. So when you play, it comes forwards, even though I'm writing this way. It comes forwards. Yeah. But I'm actually a nice guy. At Winco, there was a lady who was chatting me up. She was the clerk checking me out. And no, I don't know what the laughter is. I just said she was chatting with me and she said I was buying fries. And she said, oh my God, I love these fries, blah, blah, blah. And then I had a bag. Now, Winco is a employee-owned store. They don't actually bag your groceries. So you have to bag it yourself. She very kindly was bagging my groceries. And here's what I do. I'm just showing you I'm a fair guy. I walk up to the manager. I call the manager. I walk to the manager and I say, please reward her. She offered outstanding customer service. He's like, thank you. He shakes my hand. Thank you so much for saying that. Because, hey, they offered me good service. But on the other hand, so once again, JVD, Yelp review, good Yelp review. She was called Terry, T-R-R-Y. Because I said, Terry, she did a good job for me.
Where's the E at?
Huh?
It's just T-R-R.
I said T-E-R-R-Y. Okay, guys, I'm going to scroll down. And I want you to copy this entire figure. With all these points. This point is optional. This is a quick rough graph. Copy on that point.
Okay.
Shh. Okay, quick. We have like 13 minutes left. And I have like 5 problems to discuss. But each is kind of short. It's like Baba. It's like others are scandalous and Baba just nods maturely. Yeah, okay, that makes sense. Just so that you know, in the other AB class, I said just like Miss Purcell. I use Purcell. Purcell is super cute. She's a short girl. Oh my God, but she's in volleyball.
She's good.
She's good? I didn't see her play though.
She was at work.
Oh yeah, her left arm. Okay, this is, because I'm a student of patterns, this is Miss, what's her name now? Reining. This is Miss Reining's favorite shot. No matter how the ball comes, this is Miss Reining.
She has.
That's her job.
No, that's not my point. I've never seen you play. I don't know what position you are. I'm just saying, I'm so smart, I figured out the pattern. No matter what, this is what Reining always does. And this is Eunice, badass. No matter, like, oh my God. She's like super. I was afraid in the stands, like, oh my God, I hope she doesn't hit me. You played like the captain of the other team. The captain of the other team was also like,
Yeah.
did you observe?
From
She's
the same position.
like badass at everything. Okay, did everybody take this down? Okay, we're discussing a word problem that comes on the AP exam. Ms. Rios and Ms. Marzo will tell you what's going on. So first of all, I want you to read the English sentence. Read the English sentence, please. And speaking below the board, please. It says, the function below gives the rate of change of the volume of water in the tank. So here's my question to you. Is the graph they've given us, think before you answer, don't just blurt out something. The function f of x, or is actually the derivative f dash of x? Nobody speaks. I'm giving you thinking time. The answer to the question is here. Read the paragraph. The paragraph tells you which one it is. So my question to the class is this f of x or actually f dash of x that they are giving us? Chorus? F dash. Why? Because of this word rate. Okay, the rate means derivative. So here's what we'll do. So write this down. I'm giving you power notes. So in these kind of word problems, you always want to define the original function. See, this comes back SSG Marzuk and Ms. Rios. So you define the original function. And its relationship with the derivative. I will show you what to write. You'll say, oh, okay, now it makes sense. I know what we're doing and why we're doing what we're doing. So I'm going to define. Keep in mind, this is the rate at which the volume changes. So in other words, the original function should have been V of t, which is the volume of water in the tank. Is that clear? The volume was the original function. And are they now giving us a rate at which volume is changing? I'm going to write something else on the board, look at it and say, okay, that relationship makes perfect sense. Yes? Because this is the rate function. It's how fast volume is changing. Observe. It's the rate of change of volume. So the rate function is actually derivative of volume. So look at what I did. So in your homework, I will guide you today. As in, do the setup. This is called setup. You're setting up the problem. Define the original function and its relationship with the derivative that they give you. Is that clear? Now the problem is stupidly easy. So keep in mind, now go to your graph and can you be smart and write down, that's clearly r of t, which is v dash of t. In other words, that's the derivative function. That's the derivative. If you want, you can also do this in parentheses, like f dash. That's the derivative function. So you're treating that like the f dash graph. Is that clear? Now the problems are very easy. Once you understand that, like, I understand what's going on. This is the derivative function. Now the problems are easy. Copy down A, please. It says at t equal to 0.5 hours, is the volume of the water in the tank increasing or decreasing? At t equal to 0.5 hours, is the volume increasing or decreasing? Now I'm helping you understand what's going on. Isn't the volume guy the original function? So I'm calling this f. Isn't the r basically the derivative function? Okay, nobody speaks. Do not look at the graph. Our old rules. Do not look at the graph. First do the thinking. If the function is increasing or decreasing, what must be true? If a function is increasing, what must be true? F dash. Its derivative is positive, greater than 0, less than 0. Ooh! Isn't this F dash? Can I just see where this? So it says t equal to 0.5. Now read the graph. At t equal to 0.5, is the function increasing or decreasing? Increasing. Look at the board, please. That's 0.75. Is 0.5 here? Is that above the axis? So write down your explanation. Here's what you will write in your answer. So volume, the volume of water, or you can say at t equal to. At t equal to, was it 0.5? The volume of water in the tank is increasing since, the question says explain. I'm going to write something on the board, look at it and say, yeah, I could do that. R of 0.5, which is equal to V dash of 0.5, is greater than 0. If the derivative is positive, R of 0.5, which is, I'm plugging the derivative function, which is V dash, is above the axis. That's how easy it is. If a function is increasing, its derivative should be above the axis. And that's what we did. Okay. We're going to skip B. Guys, B is exactly the same. It says at t equal to 2. Let's just talk about it though. At t equal to 2, observe, is the volume increasing or decreasing? Are you below the axis? There's no work to be. Sure, it's just common. I know the graph. Keep in mind that's the derivative function. Okay, now copy down C, please. It says over what interval? Just do, wait a second. Just do one. We'll not do decreasing. We'll just do 1, which is increasing. It says, over what interval only do this now. So first do the thinking, then look at the graph. If you directly look at the graph, you'll forget, like, oh my god, this is the derivative function. Okay, stop. Let's do talking. Let's discuss this, then we'll write down the answer. So the question is basically saying, over what interval is the function increasing? So what should we do? Its derivative should be greater than 0. Is that the derivative function? Okay, guys, it says 0 to 4. So look carefully and tell me the entire interval. Those of you ahead, tell me what to write. 0 to 1.758. Is that it? Look at the graph carefully. What else? 3.8532. 4. Very good. The interval is 0 to 4. I hope you understood. Here, this guy. Don't forget that component. Since what we did before, r of t, which is v dash of t, is greater than 0. The slope is positive. There's nothing to memorize. But make sure you write good explanation. It's actually the derivative of the volume function. Well, v dash is greater than 0. That's what r is. Okay. Let's look at d, please. Okay. Guys, don't be cocky. In the other class, cocky kids were like Masharia. He got this wrong. Okay. He was very cocky saying, man, I get this. So copy down 1 and 2. So it says over what interval? That's a typo. It should say 0 to 4, not 0 to 24. That's a typo. So, no, it's not the same question. Yeah, same graph. So, over what interval in 0 to 4 is the volume of the water increasing at a decreasing rate and then decreasing at an increasing rate? Please don't be cocky. These are trickier than they look. For those of you who are not aware, the grading period ends this week. On Friday, the grades are due. Okay, now stop. All right. Some kids in the other class started calling out, so I have double dash with greater than 0, let's say 0. And I said, you're going to get it wrong. Better still is maybe sketch a mini graph on your sheet of paper. Let me show you what I'm talking about. It says increasing at a decreasing rate. So on your sheet of paper, if you wrote on 1, I'm going to sketch 2 graphs, choose wisely, which satisfies the condition. Increasing very quickly. It says increasing at the opposite. Increasing slowly. Increasing at a decreasing rate. Increasing but slowly. Option 1 or option 2? 2. Can you see? It's increasing but very slowly. This is increasing very quickly. Look at how it leads. So it is this guy. So write it down on your sheet of paper. You want to make a mini sketch because that graph is misleading. So I'm going to write 2 things next to this. Look at it and say, okay, I get it. Is that basically f dash is greater than 0? And f double dash is less than 0. Okay? Now, these are slopes. Remember, this is the slope graph. So the slopes must be above the axis or below the axis? Above. But its slope should be not below. Decreasing, right? So identify the interval, write down the answer yourselves. Again, you should be above the axis, but the slopes must be decreasing. One of you gets this, start calling out the answer. 0.7552, 1.758, write it down. Is there any other interval? That's it, right? Because this is positive, we're looking for concave down. So write this down. 0.755 to 1.758. I hope everybody understood how to do it. So girls writing good notes, make a mini sketch first. Make a mini sketch. Because that graph is not the graph you want. It's misleading. You'll understand the second one. Okay, write down the reason. Since r of t, which is v dash, is greater than 0, and r dash of t, which is f double dash, correct? V double dash is less than 0. As in its slopes. I'm saying r dash. I hope you understand what r dash means. R slopes. That's r. its slopes will be negative. Okay, now let's do this guy together. We're doing decreasing and increasing. Please do not look at this graph. Make a mini sketch yourselves. Sketch two decreasing functions, but now choose the one that's decreasing at an increasing rate. In other words, it's decreasing but very quickly. Or just sketch one function, like this function satisfies the condition. It's decreasing very quickly. I'll sketch two for you, you choose which one works. It's decreasing very quickly. Option 1 or option 2? 2. It's decreasing very quickly. This is decreasing very slowly. Can you see it's falling? Slopes are decreasing in value. Here slopes are actually increasing, getting flatter. So it's decreasing very quickly. So that one. So f dash should be less than 0 and f double dash is less than 0. It's concave down. That's why I said don't be cocky. It's facing down, it's concave down. It's the opposite of what you thought. Did you see that? That's why I said please make mini sketches and let the sketch tell you. Okay, let's wrap this up. Now let's look at the graph. First, easy question. Am I looking above the axis or below the axis? Below the axis. And the slopes are decreasing. The slopes are decreasing. Right on the interval yourselves. The slopes are below the axis but decreasing in value. Those of you got it? 1.7582, 2.85. Okay. 1.758 to 2.85. And your explanation will be since r of t, which is v dash, is less than 0, and r dash of t, which is v double dash, is also less than 0. I know some of you cocky kids looked here and said greater than 0, f double dash greater than 0. No, it doesn't work. That's why I say make the sketch. The sketch will tell you are you falling faster or falling slower. Okay, we're good to go. We're actually done. Thank you. Yes. Go.
Okay. Are there any questions about
Yeah, absolutely. Decreasing and decreasing it will be the others. So make the sketch. The sketch will tell you exactly what it is. Yeah. Guys, Ms. Marzuk says, Super Sweet Girl Marzuk says, should I use brackets or parentheses? The AP looks the other way. We don't care. It could be parentheses, it could be brackets, it doesn't matter. Yeah, because she refuses to acknowledge medicine, Marzuk. She's like, I don't know who you're talking about. There's only a Super Sweet Girl in this class. So I don't recognize, I don't acknowledge this person. Who are you talking about?